Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on H index. So the problem states that we are given an array of integers called citations where each citation is the number of citations a researcher received for his ith paper. We need to return the researcher's H index. H index is nothing but an author has a H index of H if H papers have at least H citations each. Okay, for example, if you consider this, in this given citation, this means that the researcher has 5 papers in total, and 5 papers is nothing but the length of this, and each of them had received 30615 citations respectively. Since the researcher has 3 papers with at least 3 citations each, and the remaining 2 with no citations more than 3 citations each, their H index is 3. So this means this 3, 6 and 5 are greater than or equals to 3, but 0 and 1 are less than that, so the output would be 3. And here 2 citations have at least 1 or equals to 1, but this is greater, so the H index would be 1. So for the brute force approach, the idea is we will try all the possible values of H from 0 to n, and for each H we will count how many papers have citations greater than or equals to H. If count is greater than or equals to H, then it's a valid H index, and we will take the maximum possible H. So let's try the possible H and we'll scan the entire array. So let's take n as citations length, and let's take a H index as 0. So now we will iterate from H0 till less than or equals to n H plus plus, and let's take count as 0 initially, and in the second loop for each citation we will check if the if the C is greater than or equals to the H. If C is greater than or equals to H, then it is a valid one, so we will count it. Okay, and after coming out, if the count is greater than or equals to H, then it is a valid H index, so we will assign it to the output, and at the end we will return this H index. Let's run the code. Okay, it is accepted. So but since we have used 2 for loops, the time complexity becomes O of n square, which is not ideal for larger inputs. So this will have some performance constraints. So let's try to think of an optimized approach. So in brute force approach, we are checking too many combinations, but we only care about the relative order, not the exact values. So sorting can help us make smarter decisions here. So the key question becomes, after sorting, can we directly find how many papers have at least H citations? So yeah, that is an optimized insight. So the key observation is, we will sort the array first. Okay, then let's take n as the length, and let's loop through I0 till n, and let's take maybe the h index. Since we sorted, it would be n minus I now. Let's assume it, but we also need to check if the citations of I is greater than or equals to the h index. If it is, then we would straight away return the h index. At the end we would return 0 if that is not found. Let's run the code. It is accepted. Let's submit it. Alright, now let's dry run for a better understanding. For example, this is the input. Okay, after sorting, this would become 0, 1, 3, 5 and 6, right? Then okay, then n would be 5 initially. Maybe we can place it here so that it would be easy to understand that it is sorted. Okay, now for each iteration we are checking the n minus ith value. So initially the index is 0 and the citations of I is also 0. So n minus I would be 5 minus 0, which is 5. This would be 5. Since 0 is less than this, we will go to the next iteration. In the first index, it is 1. So n minus I would be 5 minus 1, which is 4. So 1 is not greater than 4. So it will not enter this if loop. It will not enter this if condition. So we will go to the next loop. At I equals to 2, the citations of I is 3. So n minus I is 5 minus 3. N minus I is 5 minus index of this 3, which is 2, which is 3. So since this 3 is greater than or equals to this, then we will straight away return 3. So at index 2, we found 3 papers with greater than or equals to 3 citations. So the H index would be 3. So the time complexity for this is O of n log n, because we are also sorting the array, and the space complexity would be O of 1 because we did not use any extra space. So yeah, so we have seen the H problem, we have seen the H index problem, so brute force approach, why it failed, and the optimized approach. So that is it for today's problem, and I'll see you in the next one.